Hello, in this video, we are going to cover organizing categorical data. When you analyze a data set, you want to organize and display the data in a manner that helps you see patterns. All right, let's write that down. When it comes to categorical data, that organization is going to involve showing how often a category occurs. So that's what we're going to be interested in. All right, so when it comes to categorical variables, and the method that we're going to look at in this video for going through and doing that type of thing is going to be called the two-way table. So two-way tables are designed to go through and compare two sets of categorical variables, and you go through and you count up how many times each combination occurs, and that enables you to go through and study the two possibilities. So we're looking at two-way tables. That's the method we're going to look at. And these methods are, this method is designed to go through and compare two potentially related categorical variables. And the way that you do that is you count up how many times each combination occurs. Okay, let's see an example. It's difficult to make sense of just a bunch of words on a page. All right, so here we have an example. On the left, we have raw data. So what this raw data has is it has a column, a category for men and for women. If you recall from the previous video, we're using coding here. So coding is when we use a 0 or a 1 to represent whether the category heading is either true or false. So here, 1s represent true, so these would be men. 0s represent false, so these would be women. And then we have a second column that has whether they do not always wear seatbelts, or the opposite of that would be that they always wear seatbelts. Okay, so this is, since the heading is not always, the 1s are true, meaning that they do not always wear seatbelts, and the 0s are false, and then the opposite of not always is always. So the 0s represent always wearing your seatbelt. Okay, and so the way that we go through and construct a two-way table when we have two sets of possibilities, so there's two possibilities here and two possibilities here, is you go through and you do a column for each, for two of the possibilities here for men and women, and rows for the two possibilities here. And so you end up with 4 possibilities total. There's 4 combinations that can happen. All right, so you end up getting a two-way table when you've got two things, two categories, and each of them has two options for 4 total possibilities. Okay, so to go through and do the combinations, what we do is just go to the table. And so you want to start off with men where that's true. So we've got 2 men that do not always wear their seatbelts. And so we want to go over to the table and say, and where we've got men and not always, where that combination, where the row and column intercept, you want to put the number that matches with that. And then we have 3 men who always wear their seatbelts. So we want to go down the men column, always wear their seatbelts, and put 3. Then we have our women, and you can see we have 3 women who do not always wear their seatbelts. So we go to women and not always, and we put 3. And then we have 7 women who always wear their seatbelts, and so we get 7. So that's how you go from the raw data into the two-way table. Okay, so the two-way table enables us to go through and study this data to compare the 2 different possibilities to see if we can go through and draw any conclusions. The way that we go through and do that comparison is by finding percents. All right, so if we're going to go through and find percents, we need to add up down each column and across each row. So if you add up down the column, we've got 2 men who don't always wear their seatbelts, and 3 who do. That means there are 5 total men. All right, so if this weren't here, actually, we can go ahead and move that. That way we can go ahead, put the 5 like right there. And then we've got 10 women. Oh, actually, let me move this a little further over. You can also add across the row as well. And so you could do, there are 5 people who don't always wear their seatbelts, and there are 10 who do. The fact that you got 5 and 10 and 5 and 10 is just a coincidence. That's not always the case. That's just a coincidence. Okay, so once you've done that, you can go through and you can do percents. So we could go through and say, what percent of men always wear their seatbelts? And so to figure that out, you go to this. So we've got 3 always wear their seatbelts. There's 5 total. And so you get 3 out of 5, which equals 0.6 or 60%. All right. If we wanted to find, what percent of men don't always wear their seatbelts? We could do 2 over 5. Which is 40%. We could do women who always, whoops. I got an H in women, but women always. And if you do that, we're going to get women always, that's 7 out of 10, which is 70%. And then we have women who don't always. And we get 3 out of 10. Okay, so since we're concerned here with whether, I think it's kind of obvious what we're looking for here is we're interested in comparing the percentage of the time that men wear seatbelts versus the percentage of the time that women wear seatbelts. I think we've got enough information to go through and do the comparison, but you can also go through and do this across the rows with these other totals. So I've kind of ran out of space here, but you could go through and ask, what percent of the people who don't wear their seatbelts are men? What percent of the people who don't wear their seatbelts are women? In that case, you do 2/5 and 3/5. What percent of people who always wear their seatbelts are men? What percent of people who always wear their seatbelts are women? And so you could go through and come up with, the variations for these two rows, just like we did with the two columns. All right. And so the way that this ends up, the way that you end up doing that, let me just make this a little bit clearer, is you'll notice that the question I ask is, what percent of men always wear seatbelts? So you start off here, what percent of men always wear seatbelts? If you were going to go through and do a row, you'd say, what percent of people who don't always wear seatbelts are men? So you're reversing the order. So you'd say, what percent of people who don't always wear seatbelts I'm trying to squeeze it in here at the bottom. It's causing me to make mistakes. All right, screw it. Let's just do this. And if you had what percent of people who don't always wear seatbelts are men, then that way you'd have 2/5, which is equal to 40%. So you can kind of see, if you're doing a column here, you'd say what percent of men, you'd say this word first, and then you'd say this second, always wear seatbelts. And if you're doing it the other way, you do across a row, you'd say what percent of people who don't always wear seatbelts are men. And so it just kind of reverses it, and you end up getting, a different result, but it might be something that is of interest, so anyway, I just wanted to point out that you don't have to go down the columns. You can go across the rows instead. All right. Now, we're not really interested in answering that. I think the top part here answers the question. And what is that question? And that is there a difference between men and women when it comes to wearing seatbelts? And the thing that we can look at, and this is obviously a very small data set, a small sample size. We'll get into sample sizes and how important they are when it comes to making generalizations. But this is obviously a very small number of people, so it'd be hard to go through and use this sample to say anything about all men and all women. But from the data in this sample, 60% of the men always wear seatbelts, while 70% of the women always wear seatbelts. So you'd be able to go through and say that women are more likely to wear seatbelts, and that's the conclusion you'd be able to draw here from the data. Okay, so one other thing that I did want to mention here is that if you look at the raw data can be very confusing. So there's a reason that we went through and did the percents rather than just try and do the comparison looking directly at the raw data. And the issue that you run into if you look at the raw data is that if you kind of compare these two, you'd say, well, there's more women who don't always wear seatbelts than men. So it looks like women are more likely to not always wear seatbelts, but there's also more women who always wear seatbelts, right? You've got 3 women versus 2 men for not always wearing their seatbelts, and 7 versus 3 for always wearing the seatbelts. And so women are higher for both. And so if you just looked at the raw data and you were just looking for the biggest number, you'd end up getting a very confusing result where it looks like women are both more likely to not wear seatbelts and more likely to wear seatbelts because each is larger. And so going through and doing this percentage thing is critical to being able to correctly analyze the data. So the size of the two piles really matters. If you had the same number of men and women in the data set, then you could just look at the raw data. So if we had 10 men and 10 women, then you'd be able to go through and look at the raw data and be able to say which one there's more of. But when there's size differences, between the data that's in your table, you need to go through and do an adjustment for that size difference before you can go through and do the study. So I want to show you a different example that illustrates the same thing. So size comparisons are critical when it comes to looking at data. So here's another example. You've got 10 US cities and the number of burglaries that were reported. And so the question that is given to you is, which cities have the most, in what place are you most likely to be burglarized? So do you believe that you'd be most likely to be burglarized if you lived in Houston? Would you be the most likely to be burglarized if you lived in Chicago? Would you be most likely to be burglarized if you lived in Memphis? And so your first thought might be, oh, it's right here. I could just go through and look at this row here, which gives me the number of burglaries that occurred in each one of these places. I look at this and I say, you know what? There are 20,000 burglaries in Houston. Thus, I'm most likely to be burglarized in Houston. That makes sense. It's a plausible thought. However, the issue is that these cities are not the same size, okay? And so because there's a size difference, if Houston is more than twice as large as, so you can look at this, you got Houston has twice as many burglaries. If Houston is more than twice as large as Memphis, then actually you're more likely to be burglarized in Memphis than in Houston, okay? And so the size difference between the cities is going to affect it's like the equivalent of a percent. It's going to affect the ratio between burglaries and the number of people in a place. And so you cannot go through and just look at the raw numbers when you have things that have different sizes. So you need to go through and think about that when you're looking at data. All right. And so what we can do to this table to go through and try and answer the question here is we can add another piece of information. We can add population. All right. And so now you could go through and with population on there, you could start to think about, which place would I be most likely to be burglarized? And so the question we asked before, you can see there's 20,000 burglaries in Houston. There's 10,000 in Memphis, but Houston is like 4 times the size of Memphis. And so just to be clear here, if a place is 4 times the size and the crime is the same, then the number of burglaries should be 4 times, right? So if Houston had the exact same amount of burglaries per person as Memphis does, and Houston is 4 times the size, then the number of burglaries should be 4 times as much. Since the number of burglaries is not 4 times as much, you're actually more likely to be burglarized in Memphis than in Houston. Okay, so if that's really complicated and you're swimming, what you can do with this is you need to go through and do the equivalent of what we did with the percent. So what did we do with the percent? We went through and we took the thing that we're interested in and we divided by another number, right? We divided by the whole. So you had 2 men who didn't wear their seatbelts and there were 5 total men. And so you divided the 2 to get a percent, to get a ratio. So what you want to do here is you want to do the exact same thing. And the thing that you want to divide the number of burglaries by the size of the place, by the population. So you want to take this number here and divide by this number here. You do that, you'll create a ratio, which is the number of burglaries per person. Okay, and then once you have the number of burglaries per person, you could then compare all of the results and see, which has the most number of burglaries per person. All right, so so we've already done that. Let's see what that table looks like. Okay, and so the result here we can see is they actually didn't go through and display the number of burglaries per person. They displayed the number of burglaries per 1,000 people, but those are very similar. They just went through. They took this number, divided by this number, and then they multiplied by 1,000 so that the numbers are not too small. Okay, so yes, if you go through and take 19,858, divide by 2275221, what you're going to get is 0.000873, I think. And so what you do is multiply by 1,000 to get to 8.73. So they did this right down the line. And what it gives us is this is the number of burglaries per 1,000 people. And now you can go through and take a look, which place are you most likely to be burglarized? That's the place that's going to have the highest number of burglaries per 1,000 people, right? Think about it. You take 1,000 people in each city. In Houston, 8.7 of those 1,000 people were burglarized. In Memphis, 15.6 of those people were out of that 1,000 were burglarized. Which place are you more likely to be burglarized? The one where you have a higher number of people burglarized per 1,000 residents. And so now we can go through and kind of take a look down the table, and we can see which places have the most and the least amounts of crime, or well, not crime, but burglaries. And in this case, you can see that Memphis and Indianapolis, those are the places where you'd be most likely to be burglarized because they have the highest number per 1,000 residents. And then the number that just really jumps out at you is, because it's kind of astonishingly low, is the number for New York City, 1.65. That's 10%. That's 90% lower than the number for Memphis. It's 10% the size of the number for Memphis, which is kind of amazing. So I don't know if this is real data. So this is just data from the textbook. But it is interesting to go through and do the comparison and see how small New York is, how high Memphis is by comparison between the two. So 90%, fewer burglaries in New York City than Memphis. That's kind of amazing. Anyway, so that's it. That's our video for this week. Just make sure when you're going through and you're studying data, you do want to make sure that you have the equal size things that you're comparing. And if not, you need to do a size adjustment by dividing by the size. Okay, so thank you for watching. I'll see you next time.